Welcome to today's webinar, Building Real-Time Processing Data Analytic Applications on AWS. Our presenter today is Keith Stewart. Keith is a specialist solutions architect at Amazon Web Services in Boston, specializing in Amazon EMR Hadoop as a service. He helps customers understand and architect solutions using Amazon EMR, Apache Hadoop, Apache Spark, and other AWS services to achieve business aims. He has decades of experience working with large-scale data in a variety of industries. Today with us, we also have Karthik Snonti and Tony Nguyen. They will serve as our webinar moderators and will engage with you and answer your questions throughout the presentation today while Keith presents. Keith, welcome. The floor is now yours.
All right. Well, thank you, everyone, for attending. We're going to cover an interesting topic. It's growing in interest with the advent of IoT data, real-time clickstream analysis, etc. The desire to be able to ingest that data and process it, analyze it in real time is a growing use case. So I'm going to talk about how we can actually implement a real-time processing application on AWS using a variety of services. What I'm going to cover are three main topics. We'll do an introduction to Amazon EMR, get everybody up to speed on what EMR is. We'll talk about Kinesis, and then what I'll do is talk through what an actual real-time processing application looks like, what the components are, and we'll really illustrate it with a demo. And at the end, we'll talk about some best practices associated with real-time processing. All right, so let's jump in. So what is Amazon EMR? EMR is an AWS web service designed to make it easy to quickly and economically deploy distributed computation to process and analyze a massive scale of data. It, of course, includes Hadoop, but not just Hadoop. It also includes applications like Spark, Presto, and a whole host of other applications from the Hadoop ecosystem. So there are 6 key benefits to EMR. First of all, it's really easy to use. You can go to a single web page and within minutes have an EMR cluster up and running. It takes care of all the details of provisioning EC2 instances, spinning them up, and distributing software to the nodes. It offers low cost in a number of ways. The key one is you pay an hourly rate. And when you are done with the cluster and you terminate it, you cease to pay any more for the cluster. There are other cost benefits around the decoupling of storage from compute, and also the ability to leverage spot instances, which are our pool of unallocated EC2s that customers can bid on. Third benefit is the elasticity. So you have the ability to expand the capacity or shrink the capacity to suit your workloads. It's reliable, so EMR will monitor the health of the cluster and automatically replace any nodes that die or any nodes that become unusually sluggish. It's secure in a number of ways. You can deploy your EMR cluster, which is essentially Hadoop as a service plus the other applications. You can deploy that within a firewall, within a VPC, AWS Virtual Private Cloud, and you can put it into a private subnet. You can do end-to-end encryption. We have HIPAA and PCI applications running on EMR. So you have all the means to provide as much security as you need. It's also flexible. Once you deploy an EMR cluster, it's yours to do as you wish. You have the ability to tune it, to configure the different applications on it. You have the flexibility to install whatever software you need on it. All right. The components of EMR are shown here. So from the bottom, you can look at the storage. There's a variety of storage technologies that EMR can interface with. Of course, HDFS is there, the traditional Hadoop, but very importantly, EMR can work directly, read and write directly with S3 by virtue of a component called EMR FS. EMR file system. Above that is Yarn. Yarn's the resource management. And you can run now batch and interactive and in-memory applications. Some examples are there, Tez for the interactive, Spark for in-memory. And then a whole host of applications can run on it, shown at the top, the Hive, Pig, Spark, and so on, Scoop. HBase is popular. It's used as a NoSQL database that runs on top of Hadoop. And an increasingly popular application is Presto, which gives you ANSI SQL query capabilities at petabyte scale. That runs on top of EMR as well. On the right, there's a block showing how people can and systems can interface with EMR. It includes Hue, which is a web UI that allows you to enter SQL queries and to manage the metastore. Zeppelin is an interactive web notebook that allows you also to submit SQL, but also programming code and execute that on the cluster and see the results, but also see charts and graphs. We'll actually see Zeppelin in action in our demo. Ganglia is a monitoring application. It's used to help you understand the health and the performance of your cluster. And then Hive Server 2 and Spark with its Thrift server, they expose JDBC and ODBC connections for client applications to interface. You can submit jobs to EMR in a variety of ways. The first one is showing you can submit a Spark application using a STEP API. And you can also use a very popular service, our Lambda, AWS Lambda, which is a serverless compute system. You upload your code to the cloud, and then as data arrives and requests arrive, that code gets executed. Lambda can submit jobs to EMR as well. And then there's a variety of pipelining or solutions. AWS Data Pipeline is one powerful one. There's a whole bunch of open source ones, Uzi, Airflow, Luigi, and so on. So there's a variety of ways to submit work to EMR. I talked about storage. This shows the variety of storage technologies that EMR can interface with. In the lower right corner, you can see the S3, as we mentioned, using EMRFS. Lots of value and lots of benefits to having your data in S3. The 11 nines of durability, very low cost. It's 3 cents per gigabyte month. Data lifecycle policies, all kinds of security capabilities and access restrictions, and so on. So rich capability, and most importantly is elastic storage capacity. You don't need to change your cluster size to accommodate more data, to store more data. S3 will take care of that. And if we go clockwise towards the left, you can also see Elasticsearch can interface with EMR. Amazon RDS, our relational data service, with a variety of relational databases in behind. Amazon DynamoDB, our NoSQL solution. Over to the top right, we have Amazon Redshift, which is our data warehouse technology. Kafka for ingesting large amounts of data. And then, particularly relevant for today, is the Amazon Kinesis service, which allows for elastic ingestion, elastic capacity around ingesting data from outside the cloud into the cloud, where it can be processed and analyzed in large scale. I mentioned a lot of applications on EMR. So we're at now EMR 5. We now have 16 different Hadoop and other applications that are available to be automatically installed in your EMR cluster. When you go to the web console and configure an EMR cluster, you just check the checkboxes for the one or more applications that you want automatically installed. And EMR will take care of getting that code installed and up and running. All right, let's talk about Spark, and in particular Spark 2. Spark 2 came out a few weeks ago. This is the very latest version of Spark, and Spark 2.0 is in EMR 5. a number of, well, for those that are not yet familiar with Spark, it's a massively parallel in-memory compute engine. It's different than the traditional MapReduce. Instead of doing the MapReduce paradigm, it uses DAGs to directed acyclic graphs to represent the series of computational steps before they're actually executed, and it can manage that and then do lazy computation. It can do optimizations, but the key thing is that DAG allows Spark to manage the computation in a much higher level and to do additional performance optimizations. One of the things that's possible is it minimizes I/O by storing the data in memory rather than disk, like MapReduce does, and by preferring to keep data in memory, it can work with it at very fast speeds. It uses data structures to represent data that's distributed across the cluster. The most recent one is DataFrames. We'll talk a little bit about that in a minute. And very importantly, Spark is partition aware, so it's able to make decisions that help to avoid network-intensive shuffles. Here are the components that comprise Spark. At the bottom, you have a variety of resource managers, Yarn, which is used in EMR, Mesos, and even a standalone scheduler. The Spark core takes care of the data structures and the management of the DAG. And then you have a bunch of libraries, modules, that give interesting capabilities for Spark, really a really diverse and comprehensive set of capabilities. Spark SQL for doing SQL queries on data, Spark Streaming for real-time processing, MLlib, or Spark ML today, for machine learning, and then a variety of graph processing algorithms. Spark 2 came out with a bunch of performance enhancements. We now have a second generation Tungsten engine in there. Tungsten, if you're not aware, is a system that's designed to replace the memory management that the JVM normally does. It's aimed to do that in a much more performant way. It does code generation to generate optimized bytecode. There's some improvements to the Catalyst optimizer, so queries perform better. And vectorized support for Parquet. Parquet is an emerging and increasingly popular storage format, a column-oriented storage format for Hadoop applications. I mentioned DataFrames. So DataFrames are the new addition to Spark 2.0. They incorporate datasets, which was the earlier data structure. Datasets, as I said, were distributed collections of data. They provide strong typing and can apply Lambda functions to iterate over the members of the collection. Datasets and DataFrames are, of course, classes, and so objects from those classes have a variety of methods that are available to operate on those distributed datasets. Optimizing coders help to minimize the overhead associated with serialization and deserialization. And there's a bunch of compile time type safety to make applications more robust. DataFrames, what they do is they take data sets and can aggregate them and organize them into named columns, very much like a database table, database output, where you have your sets of data, but you have a column name associated with it, and you can perform operations by specifying the name of those columns. All right. Spark 2.0 also included SQL enhancements. So the Spark Session is something new. It replaces the old SQL context and the Hive context, unifies those capabilities. It makes it easier to mix SQL and Spark programming code. Now SQL is more ANSI compliant and supports subquery capabilities. It's still Hive query language compatible, and you can still interact with tables that are defined in the Hive metastore. And finally, you can connect through a JDBC or ODBC using the Spark Thrift server. Spark 2.0 also introduced something brand new called structured streaming. Structured streaming is essentially an extension to DataFrames and Datasets, but it operates on streams. It replaces the older D stream. Spark Session is how you now access streams, so it's a more unified way of doing that. And the effect is you can better merge different data of different velocities. You can work with static data that's been accumulated over time, as well as streaming data sets, and to be able to work with those concurrently. One improvement is the use of dynamic allocation. This provides for optimal resource utilization on Spark, which has in the past been a little challenging. The way this works, Yarn dynamically adjusts the number of executors based on what the Spark application needs. It uses the details about the executor memory and the executor core settings in the configuration of each executor, and dynamic allocation is on by default, so this capability is there when you launch EMR, and it's calculating things based on the inferred details of the EC2 types that you select for your cluster. EMR, for those that again aren't completely familiar, allows you to use a variety of EC2 types to suit different workloads. So we have a family of general EC2 types, M4s, M3s, and M1s. We have CPU optimized, the C3s, C4s, and so on. And we have memory optimized. And finally, disk I/O optimized. Now these some are better at some applications than others. And so general is often good for a starting point. If you're starting out with EMR, it's great for batch processing. CPU optimized is good for machine learning, where you're doing a lot of numerical calculations. Spark, of course, is memory intensive, so memory optimized EC2s are great for that. And then applications like HBase, which prefer to use a large HDFS for storage, they would do well with disk I/O optimized. So the other thing that's in EMR 5 is the latest version of Zeppelin. Zeppelin 0.6.1 has authentication, Shiro authentication, as well as notebook authorization. You have the ability to override the storage mechanisms for notebooks. So you can now take advantage of S3 to manage notebooks within Zeppelin. Okay, then we get into the streaming components. So Amazon Kinesis is designed to make streaming scalable but easy. And so we have 3 flavors of Kinesis. We have Kinesis Streams, which is what we'll use today in the demo application. Kinesis Firehose and Kinesis Analytics. Streams is designed to be very flexible, giving you the ability to make custom producers that put data into Kinesis and custom consumers that pull data out of the streams. Firehose is designed for simplicity, but also automatic scalability, but it delivers data today to S3 and Redshift. But it makes it very easy to deliver large amounts of data in real time to S3. And Kinesis Analytics is pretty new. It's designed to allow you to apply SQL queries to a live stream on data that's flowing through that stream. All right, some concepts just to crystallize in people's minds how Kinesis works. So streams are ordered sequences of data records. The data records are the unit of data that gets pumped through Kinesis Stream. We have producers, so they're anything that can generate a record and send it into the Kinesis Stream. These are usually implemented using our Kinesis producer library that simplifies the development of producers. Consumers, they provide the endpoints that receive the records from the Kinesis stream and perform processing on them. They use the Kinesis consumer library. Features and capabilities of Kinesis Streams. So there's a PutRecords API, which is what you use to pump records in. It has capacity with a single put. You can put 500 records at a time or 5 megabytes of total aggregate payload. An individual record can be up to 1 megabyte. There's low end-to-end propagation delay. The Kinesis producer library simplifies product producer development. That's available in a variety of languages: Python, Node, JS, Ruby, and others. There's the provision of server-side timestamps to help with tracking of the history of data. And then although the data is streaming through, there is a retention or persistence of the records. It defaults to 24 hours, but you have the option to increase that to 7 days if you like. Okay, so let's jump into the real-time processing application and the components that go into that, including seeing a demo run of how we can put this together. So real-time processing consists of these 4 major steps: production of the data, collection of the data, processing, and then finally analysis, oftentimes in a visual way. We've talked about the Kinesis producer. That's what you use to get the data into the Kinesis service. Kinesis is a serverless processing service. So you spin up the Kinesis streams that you need, and then those are available for the producers to use to get data in. And then downstream, we have consumption of the data. And in our demo, we're going to use Amazon EMR to receive the data and process it. That's going to run Spark, and we're also going to run Apache Zeppelin directly on the cluster. Zeppelin is that electronic notebook, and that gives us the ability to analyze, query the data, and perform visualizations. So that's the big picture. Here's the specific tests, the specific steps that we will follow. Again, this is just summarize what we're trying to do here. So we're going to create a Kinesis stream. You'll see how easy that is to do. I created an EMR cluster. That's also fairly easy to do. A little more work than the Kinesis stream, but still pretty straightforward to do. Then we're going to start a Kinesis producer and have that start feeding data into the stream that we created up here. And then finally, we're going to perform a bunch of ad hoc analysis within Apache Zeppelin running on EMR. There is a 5th step if you wanted to reuse or continue to use the stream in an ongoing way. You could submit additional processing jobs through the step API. We're not going to do step 5 in this demo. All right, so here's all it takes to create a Kinesis stream. I could show you the web UI. It's very, very simple, but for the sake of time and to make sure that the demo goes smoothly, I'm just going to cut and paste this into a shell. So this is the AWS command line. Switch to my shell, and so I'm just going to paste that in here and hit return, and that's enough to that makes a call from my Mac to the AWS cloud requesting that a Kinesis stream get created, and it gives it the name Spark Demo. So that's what we're going to use here. All right. So if we go back here, so that was it to take care of the Kinesis stream. Very simple, very easy. Of course, there's additional parameters if you wanted to do some additional tuning, but that's the minimum that you need to do. All right, let's go to the next step. So now we're going to spin up an EMR cluster. Again, there's a user-friendly web console. If you take the simple panel, it's like a one-page specification of your cluster, and then you click launch and the cluster spins up. But for efficiency's sake, and time's sake, I'm just going to cut and paste this into the shell as well. It returned a cluster ID, so we've got a unique ID that identifies our cluster. So it's now in the process of spinning up. All I've done is specified up here the applications. Maybe it's a little easier to see here. So I've specified the applications that I want to be automatically deployed. These would correspond to the checkboxes in the web console. But I want Zeppelin and I want Spark and of course Hadoop. I've enabled debugging. I've indicated where logs should go on S3. There are three main instance groups within EMR. The master, of course, controls the cluster. The core manages data distribution and some processing. Task nodes provide additional CPU and memory, no real significant disk space. And so that's spinning up. All right, so then the next step is to spin up a Kinesis producer. So before doing that, before cutting and pasting that, let me just check that we've got our Kinesis up and running. So I'll switch to Kinesis here in the web console. I want the stream version. All right, so here you can see we've got the Spark demo, Kinesis stream, and it's active. If I click on that, then it pulls up a real-time display. We're not pumping any data into it, so everything's blank for now. Okay, good. We're good to go. So let's go back to our, what I'm going to do is I have an EC2 instance that I'm going to use as a producer, Kinesis producer. But what we need to do is pull in this jar that has a particular application that leverages our Kinesis producer library. So I'm going to copy that and go back to AWS, go to EC2, and for the sake of time, I pre-spun up the Kinesis producer EC2. Yeah, here it is here, and we're going to connect to it. Actually, I think I have it ready to connect up here. Right, so this will take me into that. Okay, so you get the splash screen, we're into EC2, we've got a clear directory. I'm going to paste in the wget statement. So we've pulled down the Kinesis producer jar. It's there. We can go Java, jar, Kinesis producer. All right, and what all this does is simulate a temperature sensor. And so it's creating a bunch of tuples that it's pumping into the Spark demo stream that we set up. So it's going to produce a bunch of records. It'll take a little while before they show up on the graphs on Kinesis to register. Probably within the next 5 minutes, we'll be able to see some data there. All right. Now, again, you saw, I'll show you the EMR cluster that's spinning up. It'll still be in the process of spinning up. It takes approximately 5 to 10 minutes for the cluster to come up, but rather than wait that long, I've got a cluster I've already spun up. So just like a cooking show, we've got something ready already further along in the process. So I'm going to go into that EMR cluster. I call it Kinesis producer. And I'm going to SSH into it. Actually, not SSH. I'm going to set up a tunnel. So I want to be able to talk to and access Zeppelin. And we'll also take a look at the Spark resource manager so you can see evidence of Spark dealing with that data. But in order to do that, we have to deal with the security. We need to set up an SSH tunnel between my laptop and the EMR cluster, and then that tunnel with a proxy plugin for my web browser allows my web browser to talk through the SSH tunnel securely to the EMR cluster and to be able to talk to Zeppelin and others. So if we click on Enable Web Connection, that gives us the directions for doing this. So we're going to open up an SSH tunnel to the master node, okay, and it explains all that. basically we're going to cut and paste this into a shell. Okay. And the next step would be configuring a proxy. I've done that long ago, but let me go to the shell, and here's where we're going to set up the SSH tunnel. So this is going to leverage the local port 8157 and do dynamic port forwarding through the tunnel to the master node. That doesn't return because it's still running. It's maintaining the tunnel. Now if we go back to this dialog, we can close the dialog, and I have to enable Foxy Proxy. Foxy Proxy, just to show you, Foxy Proxy is the plugin that allows you to deal with SSH tunnels. So I'm using one that works with the EMR cluster, and so I'll close that, and then I'll just enable that. So this is going to look for certain patterns in the URLs to decide what goes through the tunnel and what doesn't. And lo and behold, you see now we have links that are active on the EMR cluster that allows us to reach those services. So I'm going to go ahead and click on Zeppelin. Okay, and this is running on the master node. And what we're going to do, go back to our slides here, we've done this. Oh, this is just to show you the kind of records that are, the tuples that the Kinesis producer is pumping out, some device ID, some temperature reading, and a timestamp. And then for the Zeppelin notebook, one thing we have to do is to address a dependency that allows the Spark and running within Zeppelin to connect to the Kinesis stream. So I've copied that, the name of that resource that we're going to need, and then I'm going to go here. I'm going to go up here and configure. There are lots of different interpreters that can be run within Zeppelin. The one we care about is Spark. I'm going to edit that. And we declare the dependency down here. It looks like we're already there. And so I'm save that, asks if we want it. We do want to restart it so that it recognizes that connector, the Spark streaming to Kinesis connector. And then we're good. So now we can go to a notebook, this Kinesis consumer notebook. And this provides a bunch of Scala code that will be interpreted by Spark. And what it's going to do is connect to the Kinesis stream. It's going to set up a Spark session and make use of that Spark demo Kinesis stream. So here's where we're going to use the one that we set up. Okay. And so basically this block of code, when we execute it, we'll do all that setup, and it'll register a temporary table, which is part of the stream processing called real-time table, and associate that with the records, indicating some of the schema, how the data is organized, etc. And then when we execute this block, it'll actually start the streaming into Spark. And then we'll look at a bunch of graphics down below. So let me go ahead and click ready. So this is now executing this block of code. You can see it says running. Take a minute. It's taking a little longer. All right, so that finished. And this is just showing you what it did, okay? Then we're going to execute the connection to the stream, or the flowing of data from the stream into Spark streaming. So we run that. All right, so that's going to continue to run as it's processing the data from the stream. And then we have a bunch of panels that give us either table results as we query it. So here we're issuing some SQL, just saying show tables. Here's that real-time table that we created or declared up in the Spark code. Here we can get the schema for the real-time table. We just ask for a description of that, so you can see the tuple structure, device ID, temperature, and timestamp. Then we have, this got moved over. We're going to rerun this. So this is doing a group by query on, oh, what's going on? Okay, there we go. So it runs this SQL query and has the option within Zeppelin to send the results to graphs. And this is an ongoing process. And then down here, same thing, we can rerun this. And so this is looking at, it's asking for devices that had a temperature between 100 degrees and 150 degrees. And doing the group by and giving us the stats on those devices. So that's, and then this is just looking at some sample data. This table down here. So we just did a select from the real-time table. We've got device ID, temperature, and timestamp. And if we want to terminate things, we can just or stop the stream processing. We can just hit that, and that will end it. So that's it for that, for the demo. So what we've done, just to recap, we've set up a Kinesis stream called Spark Demo. We spun up an EMR cluster. I have one already fully spun up. We configured it to launch, to work through the SSH tunnel so we could access the Zeppelin running on the cluster. Within Zeppelin, we ran some Spark Scala code that tapped into the Spark demo stream, Kinesis stream, and it ran a bunch of queries and analyses on that, generated some graphs, and did all that in an ongoing way. So it was continuously monitoring the stream. All right, so let's go back to our slides. All right, so let's talk about best practices in the remaining few minutes. So best practices around Kinesis. So don't reinvent the wheel. Use the Kinesis producer library. It deals with a lot of the details for you. You should try to combine your put records to maximize the utilization. Aggregate records, in other words, and submit them together through the Kinesis. It's much more efficient. Set up CloudWatch alarms so you can keep track of how much your Kinesis streams are dealing with. So Kinesis uses shards, so it distributes the bandwidth, distributes the ingestion across one or more shards. We happen to use only 2 shards for this demo, but you can go up to 50 shards. You can go beyond that, but you have to make a request to go beyond that. But the best practice is to randomize the partitioning of the streams across all those shards using randomization. Deal with records that are problematic. Okay. Deal with them with some logic that captures them and prevents them from going through, and use the put records for higher throughput, and you can use a scaling utility to scale the streams. And then best practices around EMR and Spark streaming on the Kinesis consumption end. Use a STEP API to submit long-running applications. It's a convenient way to do that. Run the Spark application in cluster mode as opposed to client mode. use the maximize resource allocation. That will be the most efficient for Spark. So there's some internal tracking of the streams and the connections to downstream consumers. So make sure you use a unique application name for your Spark application that's going to be the Kinesis client. And set up CloudWatch alarms for EMR to keep track of performance there as well. And use IAM roles for your security. Okay, so that's it. I think we're ready for questions. Hello, Ryan?
Yes, thanks Keith for a great presentation, and now we'll move into Q&A. Go ahead and reply to the polls on the left-hand side of your screen. Keith is going to go ahead and select a few of the questions that have been submitted. I know we have a lot of questions that have come in. Keith, if you're seeing questions on the right-hand side, go ahead and start selecting some that the moderators have assigned to you. Moderators, please keep assigning questions to Keith. Keith, if you're not seeing any questions, just go ahead and sort to see all of the questions there. And
yeah,
I will go ahead and post the link to the slides here in just a minute or two.
Okay. So far, I don't see any questions specifically assigned to me, but I'll look through.
Yeah, go ahead and look through all of the questions, and then Karthik and Tony, if you can please start assigning a few to Keith.
Okay. I see. People noticed I didn't properly copy and paste the EMR. CLI. Okay, here's one. About how long does it take to, hang on, I gotta stretch this window. How long does it take to push the example data into the cloud? Oh, yeah, I should show you. We forgot to go back and look at the Kinesis. I don't know if they can still see my screen.
Yeah, Keith, we can go ahead and bring that back up.
Okay. So if we go into our Spark demo, now you can see there was, I mean, we haven't run it for very long, but you can see the data was, these are the put record requests that went in here, along with some other, latency measures as well. So there was some delay. It's about 5 minutes. It depends. I mean, if you zoom in on these, you can set the polling, so you can look at the last hours, several hours, and then there's the period, the period of data that's summarized, and that can be as small as 5 minutes. All right, I'll go back to questions. Okay, will Spark on EMR provide better query response times than Redshift? Hang on, the wrapping for client-facing ad hoc analyses. So Redshift is both Redshift and EMR are designed for petabyte scale data. Redshift, though, is better suited for much more traditional star schemas, whereas EMR is better suited for flat files, Parquet, Avro. So data, file data as opposed to so it's the schema of the data that will determine. EMR can, with things such as Spark SQL or Presto. Presto is a great solution for querying data. It will perform rows per second, running parallel scans on data within S3, for example. So they're both good for fast queries, but It depends on the nature of how the data is structured. Can the event-based trigger be set up instead of time-based? Yes. So some of those orchestration examples that I talked about, AWS data pipeline, Luigi, and those can be triggered. Those can trigger the spinning up of an EMR cluster, the submitting of jobs, and then the shutting down of an EMR cluster. That's definitely possible. Can the event-based be time-based? Yeah, I mean, the API, the AWS CLI, the SDK, those things allow you to automate EMR configuration and spinning up and operation. So in any way you can set up a trigger and hook the trigger to invoking that functionality will allow you to have a trigger an EMR. So what many companies do will have data that comes in and data that suddenly becomes available then causes an EMR cluster to get spun up and that results in processing of that batch of data. Why Spark cluster mode and why not client mode? Well, in our case, there's a lot of applications that can be automatically installed on your EMR cluster. Those are installed on the master node, and so you want to be able to use those to talk directly to the cluster. It gives you more capacity if you're working with the cluster rather than some client. Is this version of EMR compatible with what version of Cloudera? So EMR uses Apache Hadoop and the Hadoop applications from Apache. We use BigTop, which is the open source assembly and packaging mechanism from Apache. So that allows us to take the sources of data, the open source software, and rapidly assemble stuff together with our own. We have additional bits that we apply to the package when we create EMR, and that's that's all done with BigTop. So so we're leveraging the same open source as Apache. But of course we have EMRFS and other things that are added to that. Let's see, can we get the source code shown in the demo? Yeah, we're going to provide slides later. And there will be links. There are links already in the slides that will allow you to get the source code. EMR versus Lambda. When should we use one versus the other? Okay, so Lambda is terrific. It's super popular. It's serverless, so you don't need to worry about spinning up and paying for servers that are kept warm. You simply upload your code. When the data or a request comes in, your code gets executed, and when it's done the job, then there's nothing else to do. But that means that Lambda has a smaller time window within which to complete processing. It's a 5-minute window, so you can't do any large-scale data processing. You can do lots of filtering, transformation, enrichment. Incoming records can get enriched with additional related data, those kind of things, but the processing has to complete within 5 minutes. EMR, you can run huge jobs that run for hours if you like. Let's see. How is Kinesis different from Kafka since you support both? Maybe one of I guess the moderators didn't handle that. So Kinesis is a managed service. There are no servers for you to provision. You don't need to worry about EC2. You don't need to worry about provisioning storage or connecting anything. Kinesis is it's a service. You make the request for a Kinesis stream, indicate how many shards you want, and that's it. It gets spun up, and then it's available for you to start pumping data in. With Kafka, you are taking on the responsibility of administering a fleet of EC2 instances. So significantly less administrative burden for using Kinesis. It's also much cheaper than running your own EC2 servers. Can you persist results from Zeppelin to an external destination like S3? You can persist the notebooks. So when you run queries or you generate graphs and so on, those are part of the notebook, and the notebook can be saved, and you can configure Zeppelin at EMR configuration time. You can configure that to make use of S3 to persist notebooks. Does KPL have the capability to continuously pump mock data sets to the stream? Kinesis will accommodate whatever records you want to push into the stream, as long as they're JSON format, I believe. How are we doing on time? I guess we've got a few minutes left.
Yeah, Keith, we can keep going. We can go for another few minutes.
Was only the last batch of data saved as a temp table in Spark in this example? So Spark's, quote, real-time processing, to be exact, is actually a micro-batch processing, which is different than something like Storm. Apache Storm is more of a real-time process, so it's much more continuous. Spark deals with very small windows in its micro batches, so it's for practical purposes and for most use cases, it can be quite useful for processing data in a fairly real-time mode. But Storm would be, if you absolutely need absolute real-time processing, Storm would be the way to go. Spark is good enough though for most cases. Storm, then you're looking at deploying EC2 servers and administering those. On the best practices, presenter said to use the Spark cluster mode. Why not the client? I think we already answered that question. What's the best orchestration tool used together with Kinesis and Spark? Well, I mean, AWS data pipeline does more than just allow you to set up workflows among EMR. It also interfaces with a variety of other AWS services. So it's a more comprehensive one and much more AWS aware. The open source workflow engines probably could be used to accommodate the AWS services, but then you're looking at more work, more coding and configuration that's involved. All right. What is the security or potential security in the collection using Kinesis? So as of today, Kinesis is not HIPAA compatible yet, or PCI compatible. So you have to keep that in mind. Of course, as I mentioned earlier, the downstream part, the EMR, the S3, with that you definitely can implement end-to-end encryption both at rest and in transit. But Kinesis does not yet provide that. How do I install external Spark applications from Maven? Well, the Spark applications would be, I've actually done this. You can have set up. I've used Make and just Bash scripts to run Maven to build the application, and then using the AWS S3 CLI, you can move the Spark application over to S3, and then it can be pulled in from at configuration time with the Spark cluster. But you can also use the Step API. The Step API can also be invoked using the AWS CLI. does the Zeppelin graphs auto-update based on stream data? Now, currently you have to do a refresh. You have to rerun the code that updates the graph in that panel. What would you suggest the set of core cloud watch dashboard metrics for Spark? Oh yeah, I didn't show, and we're out of time, but I was thinking I would go into the web application and show you from Spark's resource history. You can actually see how Spark is actually knowing that it's dealing with all that data. In terms of setting up CloudWatch dashboard metrics for Spark, you could look at utilization. So by Spark, you really mean EMR. So you can set up monitoring of utilization, memory. So there's a wide variety of metrics. Off the top of my head, I don't have all those on the top of my mind. Is there a JSON data type for data pipeline output in the roadmap? That's a roadmap item. We generally don't comment about roadmaps in webinars. Can you achieve the stream to RDS while having Notebook getting the replica? Can you archive the stream to RDS? Yeah, I'm not sure I understand that question. All right, but I think we're also out of time. So I think I'll turn it back over to you, Ryan.
Great. Thanks a lot, Keith, for an awesome presentation, and I'd like to thank our moderators for answering the audience questions as they were coming in. If you have any topics on our previous and upcoming webinars or suggestions on the topics you wish AWS could cover in future webinars, please drop us a line at aws-webcasts@amazon.com. Again, that's aws-webcasts@amazon.com. Your feedback will help us to improve our webinar programming. Thanks to the audience for taking the time to join us today, and enjoy the rest of your day.